Assalamualaikum and welcome everyone to our video. Today we would like present to you our case study in subject Construction Technology 3 DQS 202 about Kuala Lumpur City Centre, also known as Petronas Twin Tower. Before we start, I would like to introduce to you our group members that participate in our case study. Consists of Siti Nadia Adeline binti Fauzan, Nur Aisyah binti Mastur, Nur Elisha binti Rosli, Nurul Fatiha binti Muhammad Hanafi alias Muhammad Halim, and myself, Nur Seri Sofia binti Halim. Our content for this case study, it is about background of Kuala Lumpur City Centre, types of IBS used in this project, the problem that faced by contractor or developer in this project, the solution for the problem that contractor or developer faces, and last but not least, the conclusion of this case study.
The background of the selected project of the Twin Towers Kuala Lumpur, the superstructure's construction began on 1st April 1994. The interior with furniture were completed on 1st January 1996. The spires of towers 1st and 2nd were completed on 1st March 1996. 3 years after the skyscraper construction began, the first batch of Petronas employees moved into the building on 1st January 1997. On 31st August 1999, Malaysian Prime Minister Tun Dr. Mahathir bin Mohamad officially opened the structure. The Twin Towers were constructed on the site of the racetrack in Kuala Lumpur. The initial building location effectively sat on the edge of a cliff according to test boreholes. The site included deteriorated limestone on one half and soft rock on the other. Allow the buildings to sit totally on the soft rock, the entire site was shifted 61 meters, 200 feet. The building were erected on the world's deepest foundation due to depth of the bedrock. A total of 104 concrete piles were dug into the ground, varying in depth from 60 to 114 meters or 187 to 374 feet. Each tower's concrete ground foundation, totaling 30,200 cubic meters, was poured continuously over a 54 hours period. Until 2007, the roof was 4.6 meters or 15 feet thick, with 32,500 tons and held the world record for the largest concrete pour. Battery Solitaire finished the foundation in less than a year, despite the fact that they require a large volume of concrete.
The type of IBS that used in the project is steel forward system. All the steel elements are prefabricated in factory, then only transferred to site to judge by welding or bolting at the site. The large proportion of the strength to the weight allows a long span or high-rise building. Steel forward system is one of the low-level fabricated IBS because it consists of site testing and face the problem of structural quality control. The product is usually high quality and achieve the fast construction by decreasing the use of site level and material requirements. This is the system formwork which is designed by manufacturer to replace a conventional timber formwork. The steel formwork is manufactured in the plant and disassembled on construction site. The steel reinforcement and service conduit will be installed on site before the steel formworks are installed. The installation is very easy by using simple support system. It can be described as a mold which the wet concrete can be poured into the mold and form the required shape. These steel formwork systems are subjected to quality control. This type of IBS method is considered as the low level in the construction industry. The steel formwork system that used in beams, permanent steel formwork, tunnel form and column molding forms. The Klcc towers were built using mostly reinforced concrete, with steel and glass faced to resemble Islamic motif, a religion followed by the majority of Malaysia. The first floor circular columns were constructed using steel column forms. The steel column form should be oiled before concreting. After concreting to the first floor column, the steel column form were dismantled easily. The problem faces by the contractor or the developer of the project. Every construction process faces a lot of problems before, during, and after the construction process. Moreover, like a messy construction like constructing the Petronas Twin Tower, every parties will face the problems to make the construction even better and get what they have been designed in the beginning. There are a lot of problems faces during the construction process, but I will only highlight 3 of them. Firstly, the type of soil under the building, the best material for the concrete core, and lastly, constructing the sky bridge. Firstly, the type of soil underneath the building. The original soil or land before the excavation process was an irregular one, which was a bedrock type site. Bedrock is a really hard material, like a solid rock beneath the surface material, and it is a combination of soil and gravel. This is one of the challenges to build the Petronas Twin Tower because the depth that the contractor have to excavate was about 21 meters deep, which was a height of a 5-story building. The second problem is to choose what type of material to use for the core. The engineers faces a lot of conflicts to choose what type of material to use for the core, whether to use concrete or steel to support the building's depth and life load, and for the tower to stand in the duration about 100 years and more. After some discussion, the engineer chooses to use concrete rather than steel, because the contractor that is involved in the project is more comfortable to use concrete than steel. If the engineers want to use steel, they have to use a lot of money because the limited contractor that is experienced in steel work. And if they really want to use steel, they have to hire contractors from other countries that can cost thousands of ringgits. The use of concrete is also more stable because it can face the wind, the weather, and minimize the vibration. The last problem that they have to face is constructing the sky bridge. The sky bridge is the most difficult part of the construction because they have to put the sky bridge on a high level, and the sky bridge is a 2-story sky bridge. The sky bridge was built on the ground, and they have to locate the sky bridge on the 41st and the 42nd floor. They have to lift the sky bridge using heavy machineries like a lot of cranes because the weight of the sky bridge reaches about 300,000 metric tons. They also have to attach the legs of the sky bridge to support the load of the sky bridge.
Here is the solution for the said problems. Excavation started in March 1993 after developers shipped the whole site, 90 meters, south of where it was initially designed to be. Firstly, drilling had shown bedrock irregularities at that site that would have made supporting the immense weight of the buildings an almost insurmountable challenge. So, with a newly fixed site a quick stroll away, a massive foundation was excavated. Its 21 meter depth easily capable of swallowing a 5-story building. During the night of excavation work, some 500 truckloads of earth were removed every night. To support one skyscraper with a weight of 300,000 metric tons is surely an impressive engineering feat, but to pour a foundation that can handle 2 such towers required not only a weight of structural engineering savvy, but also a largest and longest continuous concrete pour in nation history, and this is a country which builds almost everything from reinforced concrete. Each tower required an immense foundation comprising a forest of deep piles driven into the bedrock. Once 104 concrete piles for each tower were bored in the earth, a 4.6 meter thick concrete raft was poured in around them. For a staggering 54 hours, concrete was poured non-stop into the foundation raft, a truckload arriving every 2.5 minutes like clockwork. From the beginning of excavation to the completion of the massive foundation took 1 full year. Now, at last, the towers could begin their ascent. Then, the engineers found a solution to use suitable material to put Klcc for let the building stand 100 years and more. The structure of the building consists of a dual system consisting of reinforced concrete core wall system and exterior and reinforced concrete columns. Reinforced concrete was selected as the primary structural material for the lateral resisting system as used extensively in the tower because of its availability and availability of skilled labor in Malaysia in particular and Southeast Asia is general. In addition, reinforced concrete structures are utilized as primary structural material because of material supply and weather conditions. Measurement of compressive strength is the primary objective in most cases. Concrete cores can provide precise information about the strength of concrete. Cores can be used to determine the density of concrete and it also can be tested to evaluate the water absorption of concrete. Water absorption can provide basic information about the porosity and interconnectivity of pores. Moreover, cores and the drill hole can be used to evaluate the visual condition of concrete defects such as cracks, voids, and honeycombing. The last problem is about sky bridge. Finally, the sky bridge connecting the two buildings is the answer to the final challenge I can think of. The sky bridge, which joins the twin towers at their 41st and 42nd levels, is an identifiable feature of the complex. The construction, which spans a distance of 58.4 meters, is the world's tallest two-story bridge. The sky bridge is held firmly in place by a sophisticated system of harness, expansion joints, and spherical bearings, regardless of how the two towers move or rotate individually. The job of hoisting the 450-ton assembly, which include the 325-ton main framework, as well as the support legs and other equipment, over 170 meters, equal to 558 feet, above the earth, necessitated the hiring of the specialized engineering firm. The 9-step procedure took almost a year to test and design, and 2 weeks of execute, yet everything went off without a hitch.
Finally, the construction of Kuala Lumpur City Centre, or known as Petronas Twin Tower, was done after 6 years. All the problems were successfully solved by the contractor or developer involved. All the hard work that employees involved in this construction paid off with a great response from tourists and our society. However, we as a student learned a lot about using IBS. We learned all the advantage and the advance of technology to construct the building. We also learned to construct the building must have their own problem and we have to get ready to face it. And all the problems have their own way to solve. From this case study, also we can know all about Kuala Lumpur City Centre before developer until now. That's all from us. Thank you. We hope you are enjoy and get some points from this case study.